So to begin, I'd like to do a brief introduction to PMC. So Claire, if you don't mind changing the slide. Since 1979, PMC has helped over 700 companies by completing more than 7,000 performance-enhancing initiatives worldwide. As you can see here on the screen, we have a diverse set of people that we've worked with in the past. And these are current and repeat customers. Next slide, please. Today's session will focus on risk assessment, but here are the other core expertise areas that PMC has, including quality and operational excellence, laser scanning and CAD, dynamic and static simulation, and industrial and manufacturing engineering services. Next slide. Now I'd like to turn things over to Core to begin our presentation. Core, take it away.
Hello, good morning, everyone. So now I'd like to introduce myself to begin our presentation. So my name is Kaur. I'm a digital manufacturing engineer implementing digital factories in the PMC, focused on robotic cell simulation, ergonomic simulation, and also discrete event simulation through PLM platforms, especially with Siemens Technomatics platform. I have 10 years experience in this digital world, and the vast majority of my projects were aimed at the automotive industry. So that's our agenda for today's webinar. We are going to start with an introduction, an overview what risk assessment is, why and who should carry out the risk assessment, how to carry out the risk assessment, determining goals for the risk assessment process, identifying hazards, determining and prioritizing risks. We also cover the RIA-TR R15306 standard. This is the technical report for industrial robots and robot systems. We'll check performance level and risk assessment. We'll also have a quick dynamic in the robotic cell. We'll have some example focused on the robotic cell, and finally we'll enter into the Q&A section. Well, I brought this image with some hazards in a productive environment just to start. So how many hazards can you find in this image? I will leave this image for a few seconds, and at the end of the webinar, I'll bring it back with the answers. All right. So the message I want to bring to this webinar is, how can we protect and ensure the safety and the health of the shop floor operators? How to have a healthy and a safe environment for them? So this is exactly where we come in with the risk assessment process. And what is risk assessment? What is it for? Well, the risk assessment is a standardized document that help us to identify hazards, risk factors, evaluate the likelihood of their occurrence, the frequency of exposure of the operator to the risk, and also to point out control measures to mitigate these risks. So the risk assessment, it's suitable for any type of process or activity. And in this webinar, we'll give more emphasis and we'll cover examples in the robotic cell. To start, what is the difference between hazard and risk? So hazard is something that has the potential to cause harm to people, property, and the environment. So I listed here some distinct examples. So we have, for example, electricity, we have chemicals, we have operator working on the ladder, and we have people crossing the street. These are hazards because they can cause harm to people, basically. And what is risk? So risk is the degree of likelihood that the harm will be caused. So it's a combination of two things: the chance that the hazard will cause damage and how serious that harm could be. So In the case of electricity, we have the risk of electric shock. For the chemical products, we have the risk of poisoning. The operator working at height, we have the risk of falling down. For people crossing the street, we have the risk of being run over. So on this slide, just to make it clear and more visible, I have listed these examples of hazards and risk side by side. And why should we perform a risk assessment? So the risk assessment is essential because it helps you identify all the hazards in your facility that can seriously injure operators and even others in the operator's work area. So imagine the operator working in an area with a vast amount of welding robots and other industrial equipment, for example. So this can be very, very dangerous for the operator. That's why the risk assessment is so important, because it will help us reduce the likelihood and the severity of machine-related injuries by implementing control measures, protecting all the operators in their workplace. So here I have listed some basic scenarios where we should perform the risk assessment. So when a robot or some machinery is added through the process, it doesn't matter, for example, if it's a conventional industrial robot or a cobot, for example. And talking about cobot, it even add a layer of complexity, because a selling point of the cobots is that they can work side by side with operators without the need for isolation with security fences. But in reality, this is quite complex, because imagine that you have a cobot equipped with a high-speed deburring tool, for example. So this robot is not as safe as a cobot equipped with a small vacuum gripper, for example. So here, whether we have a conventional robot, a cobot, or other machinery, for all these cases, a risk assessment must be performed. A second scenario where we should carry out a risk assessment is when there is a change in the process or a change in the way the machines are used, because the operator may suffer other types of injuries. And the third scenario for perform a risk assessment is when new hazards arise. So for cases like this, a risk assessment should be performed to determine the risks and an appropriate mitigation. Let me just move one slide. Who should carry out the risk assessment? Those best suited to carry out the risk assessment on the shop floor are the engineers, analysts, technicians, the professionals with field experiences, and also engineering and consulting firms. So this person in charge needs to be aware of the process that will be evaluated. He needs to understand and be familiar with the flow of the activities. And generally, the people who are most familiar with the operations are the operators themselves, the maintenance personnel, plant supervisors. So it's advisable to ask these people questions, to interview them, because they are the ones who are most aware of the hazards in their workplace. And how should we carry out the risk assessment? Well, this task may seem daunting at first, but the risk assessment follows a few simple steps. So as a first step, we need to identify and list all the hazards. And then we must prioritize the risks. What can cause more harm to the operator, for example? And finally, we must list the possible control measures to mitigate these risks. So conducting an interview with the operator and people who know the process helps to carry out the risk assessment. And in addition, recording videos and taking pictures of the operators' workstations, the obstacles around the operator, all the areas, infrastructure, the robots working around the operator, and the machines and the production. All of these help us to analyze and identify hazards in our facility. So now that we understand why, how, and who should carry out the risk assessment, it's useful to define some goals for the risk assessment. And this is what will help us to maintain our focus and the correct direction during the risk assessment. So some questions about the security of the operators can help us on track to complete a proper risk assessment. So here we have some questions. What could happen, and under what circumstances could it happen? How often does this happen? What are the consequences of the results? How likely are the results to occur? Are there any additional control measures that can be taken? So by answering these questions in a risk analysis, you can identify which are the most significant risks for the operators and reduce those hazards. Now that we understand that the hazard identification is the core component of the risk assessment, how can we identify the hazards? So the main goal is to identify any type of mechanism, a situation, or process where the operator could be injured. A robot, for example, could be taken apart and placing the part somewhere. So could the operator's hand get in the way, for example? Or are there pinch points? Are there places where someone could get cut, for example? Are there electrical hazards? Another point, questioning operators and maintenance personnel who are directly involved in the process also helps to better understand where they are comfortable with their activities, whether they also see some hazards or what bothers them, and also how they interact with the machines. Taking pictures and recording videos of the process, the machines, the obstacles, all the areas, infrastructure around the operator, the disposition of the resources close to the operator. This also helps to have a better understanding, a better idea, and be able to identify the hazards. And additionally, it's often helpful to have experienced people and new people to the machine to review potential hazards, because this helps provide a complete picture of potential risks through both new and also experienced perspectives. Which components propose apparent risks? So here I'm seeing some examples. We have robot arm, we have fixtures, pinch points, but we can also mention welding gums, conveyors, gluing equipment, for example, and etc. So to identify hazards, we also have to consider the process as a whole, from start to finish, and analyze the different ways in which the operators interact with the robots and devices, verify ways where the operator could interact improperly with this mechanical equipment. And it's also crucial to look at how the employees who are not directly involved with the robot zone, it could be people who are simply passing through the areas, people responsible for cleaning, for example, or people from the office could come into contact with these hazards. Checking some past accident records in the area, this also helps to identify potential hazards. It's also important to examine maintenance procedure for potential risks, and also review access to the work cell for employees who are not regular operators. Like here we have some examples like visitors, contractors, and the administrative staff, for example. So now let's see a practical example to clarify this idea. So let's assume that the operator carries out the task of loading parts into a robotic cell. So one of the hazards we have is the operator manually loading these heavy parts into the robotic cell. So what are the risks of this activity? So the operator can be pinched by a clamp, by a pivot dump or other tooling in the fixture. The operator can be hit by the robot arm, and the operator can also cut himself by picking up or placing parts with sharp edges, for example. Imagine if in the same fixture where he's loading parts, a robot also performs some spot welding on the product. So in this case, a hazard would also be the weld splatter, for example. If the operator loads parts onto a conveyor, he could also get stuck by the movement of the conveyor. If he loads part into a turntable, he could be injured by the turntable movement. We also have listed here a long-term injury due to all the repeated lifting heavy parts. So on the next slides, we'll see more. We'll see other examples involving also a robotic cell. So once we get past the hazard identification step, we'll look at how we can determine risks. And at first, it can be a tricky process because sometimes it's not clear whether a process, a mechanism, or a machine poses a risk. So here are a few more things that we might consider for the risk assessment. So we have here a consultation from a certified safety representative. It may even be a work safety technician, for example. Interview and get opinions from experienced operators, because experienced operators are very knowledgeable about the process and they can help determine risks. Machinery manuals and data sheets can also contain important information that helps determine risks. We may consider local regulations and best practices to assess risk. It's important to also consider the intensity of operator exposure to the hazard, and also analyze related incidents from similar machines and similar equipments. So here we have 6 examples that can be considered in the risk assessment and help to determine risk. So now that we have some ideas on how to determine risk, we are getting into the phase of how we can prioritize them. So prioritizing risks is another critical component of the risk assessment process. So also listed here, we have some examples that help with the risk prioritization process. So we can evaluate priority by analyzing how severe the risk is and the probability of the incident occurring. It's also recommended that the final order for the risk assessment come from judgments and analysis made by a team of technical people, engineers, and specialists with individual perspectives, individual interpretations, and knowledge of the workplace procedures. And performing a risk ranking also allows you to determine which hazard should be considered, should be addressed first. And now let's focus a little more on the robotic risk assessment part. So the industrial robot safety standard, the Real Technical Report R15306, requires that a risk assessment be carried out on every robotic system. So this includes determining what the robot will be used for, hazard identification, risk analysis, risk estimation, risk evaluation. And although this is a documentation specifically for robotics, this documentation can easily be adapted for the user on other machine safety hazards, for example. It's not limited to robots. And then using this methodology, the person responsible for the risk assessment document calculates the initial risk of injury according to a potential hazard. This person also analyzes and implements control measures, and also calculates the residual risk, which would be the final assessment after implementing our control measures. The risk here is determined by three important criteria. So we have severity, we have frequency, and possibility of avoiding the likelihood. So the severity is the degree of a possible harm. It can be, for example, a bruise or cut, a fracture, or even death, for example. The frequency is the frequency at which the operator is exposed to the hazard. It can be annually or monthly, weekly, daily, hourly, or even constantly. And the possibility of avoiding is the ability to escape from a hazardous situation. For example, avoidable, possible under certain circumstances, or impossible to avoid. So now that we understand that risk is determined by severity, frequency, and possibility of avoiding, we enter into the combination of these three factors, what we call here as the performance level. So the performance level is developed based on the combination of these three factors, used to define the ability of safety-related parts of control systems to perform a safety function under foreseeable conditions. So the greater the risks, the greater the requirements of the control systems. The hazardous situation is classified into 5 levels. We have the PLA. This is a low risk to the operator, and we have at the other end we have the PLA. There is a very high risk to the operator. And here we have a graph to exemplify what was commented on the previous slide. So this chart can be used to determine the required performance level. So we have here in this graph our combination of severity, frequency of exposure to the hazard, and possibility of avoiding. So on the right part of the graph, we have some subclassifications. So for severity, we have levels S1 and S2. Severity S1 means slight injury that's normally reversible, like it could be a scratch, bruise, laceration, medial health effect, a cut, minor burn, for example. Severity S2 is it's serious. It can be a reversible injury. It can even be death, for example. So in the S2 severity level, it can be classified, for example, major bone fracture, like hands, arms, legs, or a temporary major illness, loss of 1 or 2 fingers, amputation, permanent loss of sight, or some other critical injuries, for example. For frequency, we have levels F1 and F2. Frequency F1 would be a low exposure time. That is the operator is exposed to the hazard annually, monthly, or weekly. For F2 level frequency, it's the exposure time is more frequent and continuous. So the operator is exposed to the hazard daily, hourly, or even constantly. For possibility of avoiding, we have levels P1 and P2. So possibility of avoiding P1 would be something possible to avoid, or possible to avoid under specific conditions. For possibility of avoiding P2 would be something impossible to avoid. And here on the left side, we have all the combinations, S1, F1, P1, then we have performance level PLA. S1, F1, P2, we also have PLA. So we have all, in this chart, we have all the combinations of severity, frequency, and possibility of avoiding that bring us the performance level. So now let's get into a practical example. So here we have a robotic cell. We have an industrial robot and a turning table where the operator loads some reinforcements, and then this table rotates and the robot performs some welding. So we have also we have the robotic cell fencing to isolate all this area, and that looking purely at the operator's area where he's loading parts to the robotic cell, what kind of hazards can we observe here? So in this scenario, we already have some control measures implemented, but we can mention as the hazard we have here. We have the interaction and the exposure of the operator to the robot, the operator being hit by the robot when performing its activity. We have weld splatter, for example, the operator being pinched by a clamp or other tooling in the fixture, and even get hit by the turntable. So these are some of the hazards that we can see purely in this 3D drawing. But for an assertive risk assessment, all the infrastructure, all the obstacles around the operator must be taken into account. And this is something that we cannot see purely in this 3D drawing. So imagine that here in this region where the operator works and load the parts, there are many cables spread across the floor. Or imagine that every hour a forklift passes behind the operator to supply some other station. So these are things that we cannot observe in the 3D, and that's why the knowledge of the process, the images of the area, and the video recordings are so important for the risk assessment process. Well, now that we know the hazards that we have in this work zone, here we have some examples of control measures to mitigate these risks. So we already have implemented here in this image. So we have the robot self-fencing, we have physical barrier between robot and the operator, we have the roll-up doors, we have individual protection equipment for the operator, we have the emergency stop button, we have light barrier that will be activated once the operator enters the work area. We also have the robot DCS, the dual check safety of the robot, that it's something internal to the robot. This is it's a kind of programming where a virtual space is defined internally in the robot where the robot can carry out its activities. So this creates some safety boundaries to ensure the robot doesn't move outside of these restricted spaces. So all this guarantees a controlled and a safe work environment for this operator here. So we've already seen the hazards and the control measures of this robotic cell, looking purely at the 3D drawing. So now let's put this into a simple table and calculate our performance level. This is our last step. So on the internet, it's possible to find some spreadsheets suitable for risk assessment. Here we have a more simplified version. Well, here the activity of the operator remains the same. The operator is always loading the parts on the turntable. So in the first column of our table, we have listed the hazards, the same as mentioned earlier. And then we have for each of the hazards the level of severity, frequency, possibility of avoiding, and the combination of these three factors that is our PL, the performance level, but before the inclusion of the control measures. And next we introduce our control measures. And then we obtain a new degree of severity, frequency, possibility of avoiding, and finally a new result of performance level. So in the first line, we have the hazard of the operator being hit by the robot while the robot performs its activity. So here we have the severity grade S2, It's a serious injury, and it can cause even a fatality. So the frequency is F2 because operator is constantly minute to minute loading this station. And the possibility of avoiding is also P2. There is no way to avoid it. So we then obtain the performance level PLE. That's a very high risk to the operator. So what can be done here to improve the level of performance and the operator safety? What kind of control measures can be implemented to mitigate these risks? So here we have listed some. We have roll-up doors. We have vertical laser scanners. We have scanners. We have active robot DCS, for example. And with these control measures, we reached a new degree of severity, frequency, and performance level. So from S2, we lowered it to grade S1 because the injury is not so serious anymore. We already have in place these measures implemented, and the robot is not directly exposed to the operator. We have a physical barrier and roll-up door to prevent a possible collision. The frequency in this case is the same because the operator continues to load parts constantly every minute. And the possibility of avoiding this hazard also changed after implementing the control measures because now he manages to avoid the hazard. It's not directly exposed. And so we have a possibility of avoiding P1. And the combination of these three factors bring us the PLB performance level. So we go from a very high risk for the operator to a low risk for the operator in this particular activity. In the second line, we have the hazard of the operator dropping the part when loading it at the workstation, or even when the operator is picking the part from a rack and walk to the station, for example. So here we have the severity grade S1 that can cause a slight injury, or the operator can cut himself. The frequency is F2 because the operator is constantly every minute loading the station and picking up parts. And the possibility of avoiding is P1 because that's something that the operator himself manages to avoid. We then obtain the performance level PLB. Okay, that's a low risk to the operator. And what can be done here to improve the level of performance and the operator safety? What kind of control measures can we implement here? So again, the operator can go to some training or use standardized work instructions, can use also personal protective equipment. So this was already a low severity hazard. So in this case, we remain with the same degree of severity, frequency, and possibility of avoiding. So we have exactly the same performance level. So in this case, PLB, it means that we have a low risk to the operator. And on the third line, we have listed here the weld splatter hazard, for example. Here we have the severity grade S1. This is a mute injury or a mute ill health effect. For example, the frequency is F2 because the operator is constantly every minute loading the station and the robot is always welding. The possibility of avoiding is also P2. It's something that the operator cannot avoid at this moment. And we then obtain the PLC, the median risk to the operator. So what can we do here to improve the level of performance and the operator safety? What kind of control measures should we implement here to guarantee a safety environment for this worker? We can implement here the roll-up doors. We can implement some physical barriers. The operator must use the personal protective equipment, for example. So implementing these control measures, putting these control measures in place, we reach a new performance level. So we remain, as we can see, with the same severity level as one, because anyway, it's a mute injury, a burn, for example, and the exposure frequency is lower. There is no longer interaction with the weld splatter. And so we have frequency level F2 and possibility of avoiding this hazard as well changes after implementing the control measures. Because now the operator manages to avoid this hazard. He's no longer intimately exposed to this hazard. So we have the P, the possibility of avoiding P1. And the combination of these three factors bring us the PLA performance level. It means that we move it from a medium risk for the operator to an insignificant risk for the operator. And finally, we have listed here the hazard of the operator being hit by the turntable. We can have here the turntable movement. So here we have the severity grade S1. That can be a light injury, a scratch, cut, or some bruise, for example. The frequency is F2. So the operator is constantly, every minute, loading parts in this station, in the turntable. And the possibility of avoiding is P1. It's something that the operator manages to avoid. The operator manages to escape this turntable movement. We then obtain PLB as performance level. It's a low risk to the operator. And what can we do here to guarantee safety to this operator? Well, in this scenario, we can provide again some operator training, standardized work structures, protective fencing to isolate this turntable rotation, and also the personal protective equipment for this worker. And with these control measures implemented, we obtain in this case the same performance level because it remains a mute injury and the frequency of exposure and the possibility of avoiding are the same. We then remain here with a low risk for the operator. So let me move to the next slide. Okay. So basically here, going back to the image from the beginning of our webinar. So here I have that image with our productive environment. How many hazards can you find? So let me just advance one slide so we can see our answers. Okay, so we have listed here 10 hazards. We have eruption on the ground. We have unsecured chemicals. We have machine guarding lifted. We have water on the floor. We have stacked materials unevenly. We have this person walking in front of the forklift. We have some pallets in number 7 blocking the fire exit. We have the forklift stacked too high. The driver can't see what is in front of him. We also have in 9 here, we have this cup of coffee in the productive workplace. We have finally here in 10, this operator carrying many boxes and this worker cannot see what is in front of him. Okay, let me just advance one more slide. Okay, so our webinar has come to an end. So today we did an overview of what risk assessment is, why, who, and how should perform a risk assessment, determining goals. We learned some ways to identify hazard, the risk prioritization. We saw a little bit on the RIA Robotics Industry Association. This is the standard regarding the methodology of the risk assessment for machines. We talk about the performance level, and we enter into that practical example in the robotic cell. So let me just move one more slide. And thanks, everyone. So now Brian will move on to enter the Q&A section.
Yep, thank you, Cor. So now we'll enter into the Q&A section of the presentation. If you have any questions that you'd like to ask Cor directly, please be sure to use the Q&A feature on the bottom of your screen and type in any questions that you might have for Cor. We did have a few questions come in, so we'll get started with those. So Cor, the first question that came in is, how can a company ensure that a robotic risk assessment process is effective?
Okay, a robotics risk assessment. So, so to ensure that the robotic risk assessment process is effective, the company should conduct through an ongoing risk assessment of all robotic equipment. The company should also provide some adequate training to all the workers in their workplace on the use of the robots, the use of the machines, and all the associated hazards, for example. The company also should regularly review and update the risk assessment and all the control measures as needed. For example, the company also should encourage open communication and opening of any incidents or near misses involving these robots. Another point that the company should also ensure that all the relevant regulations and the standards are being met. And it's also important that this company seek for external expertise like engineering or a consulting company, a safety consultant, an engineer, or some robotics specialist.
Okay, thank you, Cora. The next question we had, how often should a risk assessment be conducted?
Okay, that's a good question. The frequency of the risk assessment can vary depending on the situation. So so in some cases, like in a high risk workplace setting, it may need to be conducted on a regular basis, like annually or semi-annually, for example. If we have other settings, for example, in a low risk workplace, small a productive environment, a risk assessment may only needed to be conducted once or as needed, for example. So it's important to regularly review and update this risk assessment as the conditions change or if new hazards emerge, for example.
Okay, thank you, Cora. I don't see any further questions coming in at this time. So with that, we'll close the Q&A session. If you'd like to advance to the next slide, please, Cora. So that will conclude today's webinar. I'd like to thank everyone for your participation. For a schedule of upcoming topics, please be sure to visit our website at www.pmcorp.com. Click on the resources tab to see our calendar for upcoming webinars and presentations. There will be a recording of this webinar that'll be going up on our YouTube channel either later today or early tomorrow. If you'd like to check that out, it's our YouTube channel is PMC Videos. That's videos with an S and all one word. Please be sure to check that out. If you want to review the slides or share it amongst your colleagues, we recommend you do so. Also, if you want a general overview of our risk assessment services, please be sure to look at the link that I provided in the chat box. If you want to go check out our website and review our material on risk assessment, there's the link for you. But with that, that'll conclude today's webinar. I'd like to thank you all again for joining us today, and I hope you all have a great day.
Thank you all. Have a great day.